Hey everyone, this is FixReef, and today, well, you guessed it, we have yet another EB832 up for repair. I just received this unit from a fellow reefer, and the problem described is that this unit does not connect to the main head unit. Let's power it up, see what we get first. Do we get any lights? Alright, so you've heard the clicks from the relays. You also heard the LED coming on. It's just sitting there blinking slowly. Let's wait a little bit and let's see if any of the indicator LEDs for the outlets are going to come on. It's supposed to time out eventually from attempting to communicate with Apex head unit and have the status LED lit up in the fallback mode. Okay, so it timed out, and we have three status LEDs on, indicating that a couple of outlets are on. So this tells me that, and I heard the relays clicking, so perhaps the 12-volt power supply is actually working. It may or may not be, but we'll find out. But other than that, it should not be connecting to the head unit. In fact, what I'm going to do is I'm going to test to see if it comes up on the head unit as well. Okay, so I have my classic head unit on. Let's see if it will connect to the EB832. It will not be, the EB832 will not be recognized, but if it's actually doing things, it will at least be marked as a known module in the classic unit. So let's see what it does. It also is supposed to be done blinking here if it's communicating successfully. And it's not done blinking. It cannot connect to Apex. I think we know that there is a problem. Right, it's definitely not communicating with the head unit. Okay, I'll disconnect everything, power it off. Let's take it apart, see what's inside. I'll remove the cover, disconnect it carefully so that we don't damage the ribbon cable of the connector. All right, the cover is off. All right, so what we see right away is that there is an old 12-volt power supply, the power supply that usually requires an upgrade for it to work properly. We'll see if it's going to work even the way it is, but chances are that it will work for now. Then we have a 24-volt power supply. Otherwise, I am not seeing any immediate damage to this. We'll get to it. So first, let's plug in, see if we get the status LEDs on both power supplies. Okay, so the 24-volt power supply is on. The green LED is on. The 12-volt power supply is also on. You can see that the LED is on. I'm not sure if the fan is going to start spinning, but it's probably still waiting to connect to the Apex and timing out. Okay, let's look at what we have on the other side. Disconnect everything. I'm going to clean up this. They now like to put more glue here. Apex Neptune loves gluing everything together. Everything has glue in it. Why would you want to have glue on top of your screws here that doesn't cover the entire screw head, but only where the screwdriver goes in? Is beyond me, but I'll also disconnect the fan for now. And let's see what's on the other side. Okay. It's in a fairly good shape. I am not seeing any discoloration. I am not seeing any necessarily burned components. In my experience, when it cannot talk to apex, it likely means that this CAN transceiver is dead. So we may have to look at that. All right, let's take a look at this CAN transceiver under the microscope, because I have an idea for testing this. Okay, so this is right in the center here. This is the CAN transceiver. That's not a CAN controller, but just a transceiver. 2 pins here are the CAN inputs, and these are the outputs, the TX and RX serial outputs. So what it does is it converts the CAN signal into a serial signal, and the serial signal eventually goes over to the controller. My leading theory, the reason why it's not communicating with the apex, is that this CAN transceiver is blown. I can't prove it quite yet, other than tiny little bit of, I'm not sure what it is here, but it doesn't look too bad, but it's often that this transceiver is bad. I'm going to show you how to test for this now. We're going to be able to see, the goal is to be able to see that the signal from apex is coming in, and it's translated into serial communication on the other end of this chip, because if we do not see any signal over on the other side of this, that means that the CAN transceiver is not working properly. So first what I'm going to do is I'm going to test for the power coming in to the transceiver, because if the transceiver is not powered, we are not going to have it working at all. So first we need to make sure that there is actually power coming into the transceiver. This is a 3.3 volt circuit, and so we're supposed to see 3.3 volts on this transceiver. Again, the EB832 is now fully powered, so I have to be careful not to hit the high voltage, but I should be able to see some type of voltage on my voltmeter. You cannot see the voltmeter right now, but it's reporting 3.3 volts. Perfect. So the power is in fact coming in. Okay, now that we know that the transceiver is being powered properly, the next thing we're going to do is test the inputs and the outputs of the circuit. First, we're going to connect to the CAN bus to make sure that the signal from the apex is coming in. To do this, I'm going to use this very simple logic analyzer. You could use an oscilloscope, but if you don't have an oscilloscope, a simple logic analyzer like this will do just fine. Again, the idea is that with this logic analyzer, we're going to be able to capture the data on the CAN bus coming in from apex head unit, and also on a serial output of the CAN transceiver as it converts the signal from CAN to serial. If we don't see the data coming out on the serial side, we know that this transceiver is bad. So what we need to do is we need to connect 5 wires to this. 2 for the CAN bus, 2 for the serial bus, and 1 for the common ground. So this logic analyzer supports up to 8 channels and the common ground. So we will have no problems using 4 channels for both the CAN bus and the serial output. So to connect this, I'm going to use basic jumper wires. Let's just assume this is 5-pin jumper wire. Let's just assume that black is going to be ground. We'll use this for the serial connection, white and gray, and red and blue is going to be for the CAN bus connection. So let's attach it to the transceiver, then the logic analyzer, and see what the logic analyzer is going to show us. First, I'm going to add some flux. Don't really need a whole lot. Again, we're only connecting about 5 wires. I'll connect one side of this first. Okay, so let's do the serial side first. Let's start. Now let's see what's convenient. Let's do serial data first. Again, this is just all very temporary and doesn't need to be super secure. Now the ground, oops. And finally, the other data. Okay. Now the CAN bus. Okay. Well, it's rigged up. It's ugly, yet functional. But as long as it's temporary, I do not mind at all. All right, now that the wires are connected, we need to connect it to the logic analyzer. All right, on the logic analyzer, it looks like common ground is white and black. So let's see if we find the black wire. That's going to be black to black. That's going to be our common ground for the analyzer. Now let's use the next two channels, which seems to be purple and gray, as our serial connection, serial output out of the transceiver. And let's use, so that was channel 6 and 7. Let's use channel 4 and 5, which is green and yellow, as the CAN input. Okay, the analyzer is connected. Now let's look at the software of the analyzer and see if it catches anything. All right, so this is our logic analyzer software. Let's rename the channels so that we know where they are. Let's make this TX, RX, CANL, CANR. And we can hide these other channels so we don't have to look at them, as they're not being used. Now I'm going to power up EB832, plug it into the head unit, and see if it captures anything. So we see that the communication is happening on the CAN bus. There is clearly communication occurring. But there is nothing going on the serial bus side, which suggests that this CAN transceiver is busted. So what we're going to do is we're going to replace it and see if that's going to fix our problem. All right, so first let's disconnect the analyzer. Next, I'm going to pick the part so that it's ready for me to solder. Okay, they should be right in here. So these are the 3.3 volt CAN transceivers. Older models of Apex use 5 volt transceivers, which I also have spare parts in case I run into an EB8 or an older Apex to fix. Okay, so let's go back under the microscope and have it installed. Okay, so first let's remove the test harness. Now I'm going to add a little bit more flux, and I'm going to use my hot air to remove the chip. One pin is still stubborn because it's got a lot of heat dissipation going here because of the copper plate. Okay, so the CAN transceiver is out. We still have plenty of flux there, so I'm just going to go ahead and clean up the area. Get all of that unleaded solder out. Get rid of all of the flux. We'll need more flux, but I'd like to have the area nice and clean before I actually put the controller in place. Now let's add some leaded solder. This looks about right. Now is when we will need some flux. That's enough. Let's position the new transceiver. Now, these CAN transceivers fail frequently. And the reason they fail is not because the controller, the transceiver itself chip is bad, but mostly because there is no protection from the Aquabus circuit for these transceivers. There is a 12-volt power coming next to the CAN bus wires on the Aquabus cable. So any even minor short to the CAN pins of the communication, and it's going to fry this chip. And I'm betting that this is exactly what happened here. But we'll make it happy again. Alright, the transceiver is in. It's nice and hot. Everything's still bubbling. But that helps getting the flux off while it's still warm. That looks very nice. That looks really nice. Alright, for the purpose of this video, I'm going to actually make it less nice now, because I'm going to attach my logic analyzer back on this board. And we'll verify with the logic analyzer that now we have the signal both on the CAN bus and the serial bus on the other side of this transceiver. So once again, let's attach our serial side first. Doesn't really matter if it's the gray wire or the white wire goes over here on the left. If we start seeing some kind of signal on either one of them, we know we're done. The way how Apex communicates with these types of devices, the head unit that is that they have a special protocol. It's the Modbus protocol, which they use over the CAN sort of bus transceiver type thing. And this, in this protocol, they send probe requests first from the head unit to each of the modules connected over Aquabus and say, hey, who are you? And the module is supposed to respond with what the head unit will recognize and say, hey, I am an EB832, or I am an EB8, or I am a FMM module, or display module, or something. And once it's recognized, then the head unit is going to do the usual dance of communication. Alright, that's good enough. to ensure that the module gets proper aqua bus port and all of that, and then the head unit, and then the module is fully connected, and then it talks back and forth. But at the beginning, it's just going to be the input. That's why we saw only one input coming in and no output out of the scan bus yet. So let's see now what we get with the test harness connected. So now with the test harness connected, we're going to connect the logic analyzer back. And let's see what the software says. All right, so let's start the capture. And I'm going to connect my Apex head unit again. Capture stopped, so we'll need to restart it again. Okay. So you now see that the CAN is receiving the signal and the serial is producing the output. It's of course properly named on the receiving end. It's also receiving the output out of the CAN transceiver. So now this is going to connect to the head unit, no problem. I'm going to disconnect the head unit. Let's clean up our mess and make this look real nice again. Let's remove the test harness. And clean out the pins. And do some final cleanup. Okay, this looks nice and clean. Okay, so let's review what we've done. The problem with this EB832 was that it was not talking to the Apex head unit. The issue was related to the CAN transceiver, the first gate from the Aquabus ports to the controller. The CAN transceiver receives the CAN signal and transcodes it into the serial signal that goes into the controller pins. The CAN transceiver was busted. We've replaced it. We used a logic analyzer to verify that that was in fact the problem, because the signal out of the transceiver was not coming out on the serial side, although it was easily coming in on the CAN side. We've replaced the transceiver, and then we used the logic analyzer again to verify that now the signal on the serial side is coming through no problem. In addition to this repair, because the power supply is the old type that is going to fail sooner or later, I'm going to also upgrade this power supply, and this will complete the repair. If you enjoyed this video, please like and subscribe, and I will see you next time.